Quadratic equations. Let's put a formal definition to them. Quadratic equations have the following form: a times x squared plus b times x plus c is equal to 0. They're called quadratic equations because a pattern occurs as a result of squaring a polynomial expression. Let's look at some examples. In example number 1 here, you can see that basically what we've done is taken x plus 2 and we've squared it. But instead of writing x plus 2 in parentheses and squared, let's write it out. So we have x plus 2 times x plus 2. If we use the distributive property to multiply this out, we multiply x times x to get x squared, and then the x times 2 to get 2x. Starting with the second term of the first polynomial, we multiply 2 times x to get again 2x, and then 2 plus 2, which is equal to 4. Simplifying this down, we get x squared plus 4x plus 4. So often when we see x squared, there's no leading coefficient. When that's the case, it's understood that the leading coefficient is 1. Therefore, for this equation, a is equal to 1, b is equal to 4, and c is equal to 4. Let's do a couple more of these because they're going to be important for what's coming up. We said that the pattern of quadratic equations comes from the result of squaring polynomial expressions. What we can also do is multiply x plus 2 by x minus 2. So we get the pattern from polynomial expressions that are squared. So let's work through this problem. Again, we use the distributive property. It's almost like the problem above. Multiplying x times x, we get x squared. X times minus 2 gives us negative 2x. And then 2 times x gives us positive 2x. And finally, 2 times negative 2 gives us negative 4. If we simplify this, 2x minus 2x is equal to 0. So what we're left with is x squared minus 4 is equal to 0. Now the question is this still a quadratic equation? And the answer is yes. If you're ever in doubt, the giveaway will be that you have an x squared and that's the highest exponential value in a problem. It may seem a little strange, but here a is equal to 1 and b is equal to 0 because 0 times x is equal to 0. And c is equal to negative 4. So if you were asked to write this in the form of a quadratic equation, you could write this as x squared plus 0x plus a negative 4. And let's take a look at one more. For number 3 here, we have x minus 2 times x minus 2, or x minus 2 squared. Multiplying the x values, we get x squared. X times negative 2 is negative 2x. And then again, negative 2 times x is negative 2x. And then finally, negative 2 times negative 2 is a positive 4. So simplifying this, we get x squared minus 4x plus 4. The values of a, b, and c for this problem are 1, negative 4, and 4, respectively. I'd encourage you to work some practice problems to prepare for the upcoming material. The more experience you get, the better you'll be at doing these. Next, we're going to discuss the zero values of quadratic equations. That means finding x values that, when you plug them into the equation, will result in an answer of 0. There are 3 main ways of doing this. The first is by extracting square roots, the second is by factoring, and the third is using the quadratic equation. Let's take a break. When we come back, we'll take a look at extracting square roots and move through the rest of these methods.